Okay, see, we are now broadcasting live here today. Welcome. It's good to have you. As you can see on your screen, you've reached the Carnegie Mellon University School of Computer Science Executive Education program, the upcoming course in programming with Python. Powerful, versatile, efficient. We're going to be learning all about this program, all about this learning opportunity here. There's going to be two key areas that we touch on over the course of this next hour or so together. Firstly, what will you be learning in this program? What is programming with Python here at Carnegie Mellon University? What exactly can you expect from the curriculum? And the other key area we're going to be focusing on is how will you be learning? So how is the curriculum delivered? So here's our agenda for today. We'll be introducing your speakers here on the next slide. From there, we'll learn more about Carnegie Mellon School of Computer Science, this larger ecosystem that you're joining here in this learning community. We'll learn more about your program faculty, and then I'll make that handoff over to today's keynote speakers who are going to take you through the program overview, giving you that detailed understanding across the 10 weeks on what you can expect to learn. From there, we'll talk about next steps, and as promised, get to all of your questions in our final 10 to 15 minutes together. So with that, let's go ahead and advance forward. I warmly invite into the spotlight today's keynote speakers for a hello. Firstly, we have Anil Ada with us. Professor Ada is an associate teaching professor at the School of Computer Science, Carnegie Mellon University. Professor Ada, would you like to jump in and say hello?
Yeah, hello everyone. Thanks for joining. It's great to be with you all today. And yeah, we'll say a few more things about ourselves later on, but for now, I'll just say hi and pass it to Kelly.
Hi, everyone. I'm Kelly Rippers. Same here. Excited to meet all of you today and looking forward to telling you about the program.
Thank you so much, Professor Rivers, Professor Otta. So great to have you both here with us today. That is a taste of what's to come. We're going to be hearing a lot more from our professors here in just a moment. But as we mentioned, we wanted to set the stage for you, give you some information about this community that you're joining. If you're like me, I'm a visual learner. I like to see things out in order to remember them. And I like to think of this course as many different layers of teaching and learning. And the largest layer here, sort of housing together this learning community, is Carnegie Mellon School of Computer Science. And as you can see here, it's a well-respected and recognized internationally as a center for unparalleled research and education in computer science. And this is really a cross-disciplinary or an interdisciplinary approach to learning happening here at the School of Computer Science. You'll find world-class faculty you'll be hearing from here today, offering both graduate and undergraduate level education, as well as executive education and research opportunities that are second to none. Programs are designed for working professionals such as yourself who work in a variety of technical leadership roles. So if you are a full-time working professional, this program was designed with you in mind. As we think about the ways in which the program not only allows you the convenience of fitting it around your schedule, but also the actionable activities that are really helping you to apply in real time your learning. So the CSC is known for being at the forefront, often setting the course for advanced computer science disciplines, including artificial intelligence, computational biology, human-computer interaction, language technologies, machine learning, robotics, and software research. As I said, an interdisciplinary approach as you think about bringing together these concepts and themes in computer science. So this is the community that you're joining, a robust, vibrant academic community of faculty and peers. Expertise instructors are at the top of their field. Integration, being able to develop a suite of interconnected learning modules. You're going to see that here today. That leverage resources from across the university, as well as a reputation that is globally recognized in academic research. So you can see Forbes magazine says Carnegie Mellon is known for being at the forefront of technology. The School of Computer Science is internationally recognized. So for those of you looking to springboard into career advancement opportunities, those of you who are looking to learn and learn from the very best, you have certainly arrived at the right place here at Carnegie Mellon SCS. So with that, now is the time we talk a little bit more about the course, and I hand it over to our program faculty. Why programming with Python? There are other as a preferred programming language here. More than 1 million unique job postings in the United States have sought candidates with Python programming skills. So certainly a preferred language in the job market as well. And the scope of Python, as you'll find in this program, is certainly limitless. Data scientists, engineers, developers are all flocking to Python as the preferred language because of its versatility for applications ranging from web development to data science and from artificial intelligence to cybersecurity. Who should attend? So I promised you at the beginning we'd talk about this very thing. And certainly this is the crux of why you're here. Is this program right for me? So this slide here will be touching on the themes here throughout our session here, but it's really developed for anyone, beginners especially, who are interested in acquiring program skills in Python. So it's a comprehensive program. It's going to teach you end to end what you need to know in order to write clear, robust, and efficient code from the fundamentals. There is no prior programming language requirement. Using top-down design, effective testing, and debugging, this 10-week program is going to help you to be able to write readable programs, apply algorithmic thinking, and make the most of Python's massive number of open source libraries. So now that you are all ready to go, you know more about this program, who it was designed for, and this larger community that you're joining. And now is the time where I warmly invite into the spotlight today's program faculty to tell you more about their academic and research backgrounds, how they designed the program, and give you that detailed module by module overview. And with that, I warmly invite into the spotlight, firstly, Professor Anil Atta, to tell us more about your background and to carry us forward in the session. Thank you again for being here today. Over to you.
Yeah, hi everyone. So I am a theoretical computer scientist. So theoretical computer science is sort of like the intersection of computer science and mathematics. So computation, I mean, a lot of people think of it as like the thing that happens in your computer, in your smartphones, but the phenomenon is much more general than that. Any process that does manipulation of information, processing of information, is computation. So that can be like in the fundamental laws of physics, that can be in your brains. Obviously, your brains do a lot of computation. That can be in a social network where you can see like how information spreads or evolves in a network. Or maybe I should say misinformation, how misinformation spreads. So all of these are within the realm of study of computation. And as a theoretical computer scientist, what you like to do is first find a good mathematical model that captures the system that you have in mind. And then once you have a good mathematical model, you can start proving interesting theorems, properties about the system you have in mind. So that's generally an overview of what theoretical computer science is. So it's not surprising, I guess, that at Carnegie Mellon University, I typically teach the introductory theoretical computer science course. That all our majors are required to take. I also, from time to time, teach the introductory programming course as well. And it's for sure one of my favorite courses to teach at Carnegie Mellon. Because, I feel like really programming is a superpower. The things you can do with programming, really the sky's the limit. Your imagination is the limit. The computers really rule the world in many ways. And it's great to see that the students develop the skill and then see their excitement about learning this skill and being able to produce really interesting applications and programs. So that's pretty much all I want to say about me. Now, Professor Rivers actually frequently, unlike me, frequently teaches the introductory programming course, and I'll pass it to her.
All right, thanks so much. So hi, everyone. I'm Professor Kelly Rivers. As Anil just mentioned, I specialize in teaching introductory programming courses. So for example, this semester, I'm currently teaching one of our large introductory courses for people who have absolutely no previous computer science or programming experience. So starting from your basic building blocks of what are the core elements of a program and building up students to the point where you can start building much more complex projects by putting all these different concepts together. And that's sort of a little taste of what we'll talk to you about today in terms of how we've organized this course, how you can start from the basics and build it up into something especially interesting. And I really enjoyed teaching these introductory courses in large part because, as Anna mentioned, programming is such a fascinating skill. It's certainly fun to learn and to write programs on its own, but it's also a skill that you can apply to any field that you're interested in. And something that really makes it powerful is that you can take the domains where you're already an expert, where you already know quite a few things, and then use the skills and the concepts of programming in order to really expand what you can do in that domain. So that's an area that I think is certainly very interesting. If you want to get more into computer science itself as a domain, programming is definitely the best starting place for that, because programming gives you the language to start thinking about things like algorithms and how do I solve new problems. Outside of that, I have an interest in researching computer science education, looking at how people actually learn computer science. And I like applying different learning science principles to how we design courses in order to make sure that people can learn as much as possible. We'll just start out by talking a bit about sort of the overlying goals of the program, and then we'll go through the 10 weeks of modules to describe what you'll learn in each individual week of this program and sort of why these concepts are important. As a starting point, some of you might be wondering why we chose Python as the core language that you'll be learning in your program. And part of it is that Python is a really excellent language to learn. It's a great first-time language because, unlike some other programming languages, the syntax of Python, the way that you communicate with the computer, is fairly straightforward and somewhat easier to read than in some other languages. But it's also very powerful. There are a huge number of libraries that people have developed that let you write Python code in order to build projects in all sorts of different domains. So you can start from very basic concepts and then build them up into these more and more powerful projects. Outside of that, though, it is true that what particular language you learn as your first programming language doesn't necessarily constrain you to always working in that language forever forward. Because the concepts that you'll learn when you learn how to program in Python, things like variables and functions and loops and recursion, these are all concepts that you can then go and apply in other languages as well. So really, we're going to focus a lot on core computational techniques and ideas, and you'll learn them within the Python syntax, but you'll also be able to apply them in other languages later on if you need to pick up a specialty language for your own domain. In terms of the main goals that we have throughout this 10-week program, we want to focus on really the core skills that you need to develop in order to be a programmer, to build programs in the Python programming language. As part of that, we have these 4 core learning goals. The first one is to really identify, interpret, and apply the core building blocks that you need in order to write Python code. Writing programs is very much like putting together puzzles or building towers out of blocks. You can start from simple concepts and really just fit them all together in order to create much larger and beautiful programs. Second, we want to teach you how to use algorithmic thinking in order to discover how to put these pieces together. It's one thing to learn the syntax of a program, what a particular piece of code does. It's another to discover what types of syntax you need to put together in order to actually solve a novel problem that might be different from anything you've seen before. Learning how to think algorithmically and how to solve problems this way can be very difficult at first, but you'll find that the more practice you get with it, the easier it will get to apply these ideas. Third, we want to teach you some best industry practices for programming. So we want to go over what are ideas such as efficiency and style and different things outside of the particular syntax of a program that still matter a lot in terms of how other people will understand your programs or how quickly it will be able to run. And these will be useful if you plan to take these skills and apply them in your own industry later on. You'll definitely want to be keeping up with these best skills. And finally, fourth, we really want to focus in on how you can build on code that already exists. Again, one of the most powerful features of the Python programming language is that we have all of these libraries that people have built before, so that you don't need to necessarily write a program to do some specific action on your own. You might be able to find a library that has already implemented that action so that you can import that action in, use it directly, and then apply it to a problem that you in particular want to solve. You'll learn all of these different goals through content that will be shared with you each week through recorded lectures were given by myself and Professor Adal. and also through live office hours with the learning facilitators. And I think that our program support will talk a little bit more about how that works later on in the slides. With that, I'll pass this off to Professor Haddad to talk a bit about the curriculum.
Yeah, okay, so I guess we all know it's a 10-week program we have here, one module per week. The modules are structured in a way that, you know, you get to watch some videos us explaining the core content. You get to do some exercises to practice the new knowledge and skills you're learning at the time that you're learning. You'll have some quizzes, and then really, you know, you learn by really getting your hands dirty and practicing. So at the end of the module, you'll have a few problems, the homework assignment, where you'll get to really practice and learn the skills. Now, everything is really building up, in some sense, you can say, to the Capstone Project at the end of the program. So in that, you'll be able to make use, I mean, really showcase a lot of the things that you have learned in the program. I like to think of the 10-week program in two parts, I would say. The first part perhaps is like modules 1 to 6, including 6. It's kind of like the introductory, basic, fundamental part of programming. Like you're learning about the fundamental pieces, fundamental building blocks, and you're also learning about the Python syntax that allows you to express those fundamental building blocks. And also you're learning about the algorithmic thinking, right? So how do you take a problem and express it in a way such that the computer can actually execute and solve? So that's kind of like the first 6 weeks in some sense. And then the second part, module 7 to 10, maybe you can say it's more like at intermediate level. It's kind of the stuff that maybe separates a novice programmer from a bit more sophisticated programmer. So we're going to be talking about some interesting things in the second part. Now we'll dive into all these one by one, so I won't say more right now. So maybe let's start with module 1, and let's say a few words about each module and what you'll be learning in each module. Okay, so in module 1, we basically have a couple of goals here. So first, when we start out, we want to give you a 10,000-foot view of the basic building blocks of programming. Like, what is programming? Just having like a good understanding of what you are trying to sort of learn and achieve, and what you will see in the first few weeks of the overall program. So we'll give you that overall high-level view, and then we'll basically then start one by one going through the basic building blocks of programming and teach you both the logic of how it works and the Python syntax, like how do you express these things in Python. And at the end of it, what we really want, of course, is for you to write your first program, right? So we will set you up in a way so that you will be able to actually write your first Python programs, execute them, see them run, and see the results. Now, when you're first learning, you know, programming, you have to be patient, right? So there's a lot to learn, and at first we'll be just like babies crawling, right? We won't be able to just like start running right away. So you have to be really patient, and we'll be building up slowly week by week and try to bring you to a point where you can start running and even start flying, if you will. But that's basically module 1, to get started and write your first program. And then we have module 2, and I'll pass it to Professor Rivers.
Right. So in module 2, we're going to start introducing the idea of a logical structure, which is really a way to let your program start doing somewhat more complicated actions. In this particular module, we'll mostly look at the idea of making decisions based on certain points of data that you have. In other words, when you are writing a program, you're really trying to give instructions to the computer about how it should do a specific task. So when you're having the program make a decision, you're saying, well, if you have information that says this, you might want to do this action. But if your information says that, you want to do a different action instead. This is really introducing the syntax and the ways of thinking for making those kinds of decisions. Additionally, we'll get a bit more into the idea of functions, which will be covered originally in that first module. And with functions, we're really going to look at this idea of compartmentalizing code, figuring out how can I write a simple process for how to do a needed task, and then reuse that process whenever I need to. And how does that make the program slightly more complicated when I'm jumping between different processes that I'm running in different points in time? We'll also start talking about one of really the most core and important non-programming parts of programming, one of the best industry skills, which is dealing with things that go wrong. This is a process we call debugging with programming, and it's that sometimes you write a program that isn't doing what you want. How do you figure out what's going wrong, and how do you fix the program to make it work? This is absolutely something that professional programmers deal with all the time. And so using systematic strategies for dealing with these bugs is incredibly important. With that, we can move on to module 2 with Professor Adal.
Module 3, yeah. So module 3 is all about iteration and loops. And as I like to say it, loops gives you wings. So this is, in some sense, you can say like the final building block, basic building block of programming that in principle allows you to do and allows you to compute anything you want. So once you have loops, basically anything you want to compute in principle, you can compute it. Now, once again, of course, you know, at first, at this point, I don't want to say like, oh, we're going to start flying in module 3, but we'll understand how it maybe looks like to fly. And then as we build our muscles, programming skills, we will start to run and fly. But as I said, in terms of the content, like, you know, in principle, at this point, you would have everything you need to build whatever you wanted to build. So what is a loop? What is an iteration, and why is it important? Well, if you think about like what is it about computers that is so powerful, that gives a lot of advantage? Even though like a computer at the very base level can only understand and execute extremely simple instructions, and very important advantage it has is that it can do it extremely quickly. So you can actually execute billions, trillions of instructions per second, okay? And really, like, what we want to do is take advantage of that power, and that's a lot of power. So, and to be able to do that, you will have to use loops, right? So how do you actually express all these instructions? It's not like you're gonna like write down one after another, a list of 1,000, 1,000,000 instructions. There's a succinct way to express that, and that uses loops, okay? So in most programming languages, there are two kinds of loops. There's a for loop and the while loop, and we will be teaching you the loop syntax in Python. And also, now that you have this access to this powerful concept, well, now you can do interesting things. We will start to think about more like problem solving skills. Like when you're given now a task that you need to solve, what are the sort of steps that you should start to take in order to figure out how you can express the solution to that problem using loops, using conditionals, and so on. So we will start also that more algorithmic thinking, problem-solving aspect of computation and programming. There are also other details here, like one important aspect of programming is to make sure that the programs you write are correct. So like we will, you know, sort of discuss like how do you make sure that the programs you write are correct? And this is crucial, right? Like programs run everywhere, like in hospitals and on airplanes. You have to make sure that your programs run correctly, right? So what is the best way to make sure your programs are correct? And we'll talk about like writing test functions and the best, start to talk about the best industry practices around making sure that your program is correct. Okay, so next up we have module 4.
Yes, and in module 4, we're talking more about iteration. It might seem strange at first that we spend 2 modules on this, but This is partially because iteration is absolutely a very powerful technique and something that really does give you the ability to program amazing things, but it can also be a little difficult to wrap your head around at first. So we want to make sure that you have plenty of time to get a lot of practice with this skill and to build up the skills of programming with more and more complex iteration. So in this second week on iteration, we talk a little bit more about how to handle loops in iteration, not just with simple repeated actions, but also with more complex repeated actions. When I need to repeat something in multiple dimensions, for example, how does that change the way that I'm going to build loops in order to solve my task? We'll also talk about a different way of approaching iteration, which is something called recursion. And the core idea of recursion is that sometimes you want to solve tasks by repeating a task during a set amount of iterations and repeat the same action each time until you can calculate the result. But sometimes you want to solve tasks instead using delegation, to do part of a task and then delegate solving the rest of it to someone else. And this approach is basically recursion, this idea of repeatedly running the same task on smaller and smaller pieces of a problem. Recursion is important because it's a concept that is used in a lot of fields of computer science in order to solve problems that you can't solve using simple iteration. It really opens up the possibilities for how you can approach problem solving. And in addition to that, it's just a really interesting way of thinking that is somewhat different to how we often approach problem solving as human beings in the real world. So we'll touch a bit on how this new concept works of recursion, and we'll have you write some simple recursive algorithms based on structures we give you in the Python programming language in order to help you get used to this new concept that does often show up in more advanced programming contexts in the field of computer science. At that point, though, we should be good on iteration, so we can move into Module 5.
Yeah, so in Module 5, we are going to be talking about how to handle large amounts of data, right? So another advantage of computers is that, well, you can have huge amounts of data that a person by themselves could not analyze and understand, but we can take the advantage of computation to actually parse and analyze data. And we'll just start to begin to understand data structures and how you can actually parse data in this module. So there are different ways you can get a lot of data. It can be in the form of a huge text that you need to parse and then analyze. And so we'll be actually talking about the data structure that Python has to handle text, which are called strings. We're going to be talking about another data structure called lists that allow us to store a bunch of data in one unit. And we're going to be talking about the common data operations that Python allows in order to analyze large amounts of data. We will be discussing an important difference between strings and lists, the mutability and immutability. This is a bit technical at this point. I don't want to get into it, but this is one of the things that beginner programmers usually don't know about, but definitely should know about. So again, this is kind of thing that separates a novice programmer from a more sophisticated programmer. And at this point, we're at Module 5, we're at week 5, so we'll build more programming skills, more programming muscles, if you will. So we will be able to actually cover more interesting examples. And you will see during the module content, we'll see an example from cryptography that is very interesting, and it will allow us to, understand the string manipulation operations a bit better in that context. We'll see at the end of the module how to take large amounts of data from, let's say, a file. I mean, you can go to, for example, World Health Organization website, download huge amounts of interesting data and try to actually parse and analyze that data. You'll learn how to do such things. Or you could be you're a teacher, you have a class with hundreds of students and you want to process their grades or something like that. Again, you'll see how to do that kind of thing. So yeah, at this point, I think we're building up to more interesting examples towards the midpoint of the program. So then we have Module 6.
Yes, and Module 6, as Professor Da mentioned before, is sort of the place where we'll wrap up the core introductory elements of programming. What's really interesting about this module is that in each of the past modules, we've introduced a new computational idea, something that helps you build your stable of tools that you can use when you're building programs. But in Module 6, we'll sort of put a pause on that and instead say, now that you have all these tools, how do you decide which ones you want to use in order to approach any new problem that you're given? So in most of the problems you'll be solving in previous weeks, we'll often sort of guide you through the process of deciding, how do I put together an algorithm to solve this particular problem? How do I build up the code in order to solve this problem? And this week, we'll sort of teach you how to actually do that process yourself. To start from just a generic problem statement, you want to do X task, and how to identify, first of all, whether that problem can be solved either by following an algorithm you already know or applying a pattern that you've seen before, or in cases where it just feels different from things you've solved before, using different problem-solving techniques in order to approach the problem. Things like top-down design that lets you break up a really complicated task into smaller pieces, for example. So we'll talk about these different problem-solving strategies, and this is really crucial because when you go out into the real world later on and you want to use these skills that you've developed, you'll need to use them without guidance in order to figure out how to build up your own algorithms. So having strategies for figuring out how to design algorithms will be absolutely crucial at that point. We'll also talk about a programming best practice called style, which is figuring out not just how to write code that works, but how to write code that works and can also be understood by other people. This is absolutely crucial if you're going to be working with a team of people who are also going to be interacting with your code, because you want to make sure that the code you're writing is something that they too will understand and will be able to interface with normally. So here we're really working on those soft skills and giving you a bit more depth in that programming experience before we move on into the second half of the course and get into some deeper concepts of programming. For that, we can move into Module 7.
Yeah, so at this point, we're in the more advanced territory, I guess, in the program. So this module is about computational efficiency, and it's absolutely crucial in the study of computation and in programming. So when you think about a lot of the computational tasks that we would love to solve I should say, whether it's like an optimization problem in the industry, maybe it's some kind of a scientific problem like, protein structure, protein folding, and predicting that, or whether it's something else. A lot of the time, like we know actually we can write algorithms, we can write computer programs to solve those problems. The issue is that most of the time, the solution to get to the solution would take age of the universe or even more, right? So with that point of view in mind, you see that basically, it's not just about writing a program and that solves the problem, but it's really about writing an efficient program. Like you want to be able to get to the solution in a reasonable amount of time. And so that's like at a high level, why like efficiency is very important in one sense. But in another sense, like just think about if you're like loading a web page, and if it takes like 10 seconds to load, like you're not going to stay around, right? Like you're not going to be patient with that. There's even a difference between, 1 second and 10 seconds. So now the question is like, what is, first of all, the right way, the right language to use to understand computational efficiency, to express computational efficiency? And then also how can you think about it so that when you're writing your own programs, you have a good understanding of whether what you're writing is computationally efficient, or if it's not, whether you can do something about it. So these are the kinds of things that we'll be discussing. We'll also give you some new tools, Python tools, some new data structures like sets and dictionaries that allow you to write very efficient code, very efficient programs, and that will be a very powerful skill in your toolbox moving forward when you're writing your own programs. So then we have module 8. Yeah, and module 8 is about object-oriented programming. Some of you maybe have heard about this. It's a very popular concept in the context of programming. And this is like completely different in some sense from the previous part. This is really all about structuring, how to structure your code. Now, why is that important? Because, well, you know, we talked about, of course, like you want to write a program that works correctly. Then we talked about like efficiency. Of course, you want to write a program that is efficient, that's going to do the job in an efficient way and give you the result in a reasonable amount of time. But these are not the only concerns. Another important concern, and like Professor Rivers already talked a little bit about this, is how you write your code, how you structure your code. Are you using good style? Because your code is not going to live in a vacuum. It's going to be read by you. It's going to be read and used by other people. Other people might want to extend. So it should be understandable by another human being. And in that sense, you know, how you structure your code is absolutely crucial. There are different philosophies on how to structure code. Object-oriented programming is one extremely popular philosophy on how to structure your code. And so this will, like, after this module, you'll be able to, you know, use this philosophy to structure your own code. I think many of you will find it very intuitive and nice way to structure code. But also importantly, you know, when you are looking at other people's code online, when you're using Python's libraries, you will see that a lot of the code out there is structured using object-oriented programming. So it's very important that you know what it is and you can understand other people's code. And, you know, I talked about Python libraries and other people's code. So with that, I'll pass it to Professor Rivers to talk about that aspect of Python.
Right, so can we move forward to module 9? Thank you. Yes, so as Professor Dodd just mentioned, this module is going to be where we really get into the most practical elements of programming with Python. How are you going to build code, not just in a vacuum, not just based only on what you can code yourself, but that relies on code that's been written by other people before. As part of that, this will largely involve Python libraries. So how to find Python libraries that do interesting things that can support your own work. How to understand how these libraries work by reading documentation and using that in order to understand different functions and methods that you can call. How to actually install these libraries and start playing around with them to figure out how you can get them to work. As part of this, we'll also give you a bunch of small examples of Python libraries in different fields, such as data analysis or machine learning or game design. We won't go particularly deep into any one library because we more want to give you the skills to find and learn libraries on your own, because we expect that all of you have a very vast array of interests that are all different from each other. So you should more be prepared to use the skills we'll teach you to learn libraries in your own field, but don't necessarily expect us to go through them directly within the sessions. We'll also in this module talk a little bit about how to write write code that is based on files in your computer system. Now, this is hugely important whenever you plan to do any kind of data analysis work or machine learning work, because usually you're not basing your code just on information that's provided within the program itself. You're usually reading in information that is included in other files and using that in order to run algorithms, run processes, and create results. So being able to use files that are already in the system will be incredibly useful here. In other words, this module is all about figuring out how to take all the programming building blocks we've learned before and now apply them into practical circumstances in order to build your own projects, which leads us really nicely into our last module, module 10. And in module 10, we're really going to put it all together by teaching you how to organize all these skills into actually writing and managing larger programs that accomplish specific tasks that you're interested in solving. So as part of this, we'll discuss some general best industry practices for writing these large programs and managing them, and different tools to keep in mind when you're working in this different context, mostly because there is a very large difference between writing a single program to accomplish a very small task where that program might be 5 or 10 lines long, versus writing a lot of programs that are all working in tandem to accomplish a much broader task. That's going to require a few new skills that we'll go over in this. This will also be our opportunity for you to work on your capstone project, which I believe we're discussing on the next slide. So in each of the previous modules, as Professor Dahl mentioned before, you finish out the module by working on a homework assignment where you're working on several small programs that test the different skills that you've learned within that module. But in this last one, in the homework assignment for module 10, we'll instead have you build a capstone project. And the idea here is to use all of these skills you've learned all joined together in order to accomplish an interesting task in some other domain that you might be interested in. The way this works is that we have designed at least 3 different projects that are mentioned here, one about linguistic analysis of text, one about comparison of DNA data, and one about data analysis of social media posts. And each of these are an opportunity to guide you through a project, through guiding you through writing a bunch of small programs that will let you do something really interesting using Python code. Our hope is that through building this capstone project, for one thing, you can get experience writing a project that does something interesting, potentially in a domain you yourself are interested in, but also that it will give you a feel for how to organize these kinds of projects yourself so that you can go out from this program and actually use the skill within your own domain to build up a program that does something which is important to you. So with that, I believe we have finished talking about the curriculum. So I think we should pass it back to Marie at this point. Marie?
Hi there, just coming back into the frame here. Thank you so much to our professors for taking us through this course overview. Professors Rivers and Otta for being here with us and taking us through the content on what you can expect to learn here in the program. So we do have a couple of questions, but before we hand it over, we wanted to give you some information about next steps here in the program experience. So we talked about what you will learn, and here what we've showcased for you on this slide are some of the delivery components, some of the ways in which you'll learn. So you'll see here office hours with learning facilitators. In addition to your program faculty, you also have learning facilitators who are at the helm of your day-to-day experience. They're hosting office hours. You can bring your code, help walk through some of the exercises together, come to office hours to get your questions answered, to network and build relationships with your peers and your teaching team, and get the support that you need. If you, we heard from Professors Rivers and Otta about some of the vast interests that you guys are representing in your peer cohort, different industry areas, different areas of interest. Bring these into office hours, talk about it with your learning facilitators, reach out for some of those additional areas of support in this live context. So that's another advantage of having these sort of synchronous opportunities for you to learn live in a community setting. You know, what are some of the learning components that are live versus the recorded sessions? And Renee, that's a really great question that you put there in the chat. We've built this program, if you can think of 2 words, you can think of the word engaging. So we've already talked a lot about your peers, your teaching team, your faculty, your learning facilitators. You have a highly engaging cohort model. So you're coming together with a cohort, learning together as you go, and therefore building a highly engaging experience. The other key word here is convenience. And so some of what we've done here is designed a program, as we mentioned towards the beginning, for full-time working professionals. And we've done that in a way that allows you to have mobile access on the go. You can watch videos from your tablet or mobile device. You have access to the program for an entire year. So the program is a 10-module program, but you'll be able to touch on these themes, come back into the exercises and videos for an entire year. And most of what you see here on your screen, Renee, to answer your question, most of this is asynchronous, meaning that you're able to design a schedule within the week that works best for you. The demonstrations, coding exercises, knowledge checks, the peer discussion threads, the Capstone Project, the videos, this is all happening on the learning platform around your convenience. So these are some of the asynchronous components. Really, the synchronous components are with the office hours and webinars such as this one here. These are all recorded. So even if you have to miss a live teaching session, an office hour or a webinar, just as today's session is being recorded, so will it be in the program. You'll be able to go back and take a look at anything you may have missed. The other thing to note here is this concept of bite-sized learning. I'm just going to highlight it here for you on the screen so you can see what we're referring to here with the bite-sized learning. This is an opportunity for you to fully immerse yourself as you go, and particularly with a technical program such as this one where you're learning Python. Bite-sized learning is a chance to learn a new piece of information and then fully immerse yourself with it, tinker with it, practice and exercise before then moving on to the next piece of information. So we call this a pedagogical approach, bite-sized learning, and it's a way in which we're able to break down some of those barriers of time and space that you would find in a traditional classroom. So in a traditional classroom setting, you only have a certain number of seats in the room, certain number of minutes to get through the content. But here in the online learning environment, we're able to deliver the program to you in a way that allows you to learn at your own pace and fully immerse yourself as you go along. So a lot of opportunity here as you think about the way that this curriculum is delivered. All of this really culminating for a chance for you to earn a certificate, a credential here from Carnegie Mellon University School of Computer Science. This is an example copy of that digital certificate of completion. And certainly for those of you who shared in the chat that you're here to switch careers or springboard into some career advancement opportunities, earning a credential that formalizes your training is certainly going to go a long way in helping you reach those goals. And that's really what the certificate does. Whether or not you're going to use it for career advancement, certainly it helps to formalize your experience and your expertise here in Python, and a chance to earn a credential from a top university here at Carnegie Mellon University. So a lot of big takeaways as you think about the returns on your investment. As soon as you enter the program, you're broadening out your professional network, you're gaining peers and colleagues from across the globe. You have a chance to earn a credential here from Carnegie Mellon. And of course, all of the learning as well that was described by our program faculty, really helping you to bring into action and bring into life around your interest areas. We are joined here today by a team of program advisors helping to answer any questions that you have. So those logistical questions about when does the course end, what are the holidays, when are the office hours, I want to get them on my schedule to make sure that I'm there. Your program advisors can walk you through all of those details. So we want to make sure you get connected with Deepika. Not only the logistical questions, but also course policy information. I see some questions about alumni status, certificate of completion, what's the evaluative criteria on the program. These types of course policy questions are also best answered by our program advisors. They're the ones closest to those details. Firstly, by going over to the course enrollment page, which we have a picture of that for you here on the screen. In order to get to the course enrollment page, there's a link there at the bottom of your screen. You're not able to click on that link. We're in presentation mode right now, but if you open your chat box, you'll notice that Queenie has posted a link for us there in the chat box. If you'll open that up, you'll find it. Right there at the bottom of the chat box is a link as well as an email address. That link will take you right over to the course enrollment page. And if you click on this black apply now button, I'll circle that for you here. There's also an email address in the chat. So if you're not quite ready to put in your contact details into the enrollment form, you can simply send us an email there at cmuscs@emeritus.org. That you will find that in your chat box as well. That's cmuscs@emeritus.org. Let us know you need an academic advisor. We'll get you connected with a member of the team who's here with us live today, who's going to be able to support you with any of those logistical, policy, or registration related questions. The third channel to getting connected, as I've mentioned, we have recorded today's session. Everything here was recorded, and we're going to be following up within 24 hours to give you copies of recording today. Once you get copies of the recording, you can simply reply all and let us know you need an advisor if you don't yet have one, and we'll get you connected that way as well. We want to make sure that high level of relationship building, engagement, and support begins right here, right now. I see your question about missing the starting window, and certainly we have additional programs on the horizon, the synchronous versus asynchronous components of the program. So these are all terrific questions.
Marie, I'd like to answer that question in detail. It is a very important question. The content is predominantly asynchronous. The lectures are video lectures, but you will have 2 live lectures by Professor Rivers and Professor Ada. In addition to that, every week you'll have the option to get on a live learning facilitator session where one of our learning facilitators is able to answer any questions you have about the content or the assignments live online every week during the 10 weeks. I hope that answers your question.
Yes, thank you, Ram, for being here with us as well from Carnegie Mellon, helping to support the session here in the background. A lot of really great questions about the logistics, the grading structure, the way the course is divided out in terms of the synchronous versus asynchronous activities. I also see Yujia's question about what sets this course apart. I see you wrote this question, and some of what we've described here, the cohort model, this is not an open online course. This is not a MOOC, a massive open online course. This is a private cohort model, specialized program where you're coming through with a cohort, learning from one another, learning from your teaching team, and having a variety of activities that keep you engaged. You're getting individualized feedback on your assignments and a lot of support throughout your time in the program. If you think of the ecosystem of teaching and learning, you have yourself, your peers, your learning facilitators, your course faculty, this broader community at Carnegie Mellon, and then finally our program advising and technical support team 24/7, helping to assist you with your learning. So certainly get connected there with an advisor as you help to draw some distinctions between some of the program offerings and make a choice about whether or not this is the right program for you. So with that, I want to invite back into the spotlight for a final send-off message, our two faculty, Professors Rivers and Otta here. Any final words of wisdom? Maybe we'll start with you, Professor Rivers. Any final words of wisdom that you'd like to share as we sign off here today?
Thanks, Marie. I would just encourage you all, if you end up signing up for the program, definitely make sure that you are actively practicing as you are learning the material, because you'll find certainly watching the recorded lectures will help, talking to your peers will help, but a large part of learning a program is going to be getting that active practice and trying things out for yourself. So I strongly encourage you to make sure that is part of your own process of learning. Beyond that, get excited, because this is absolutely a fantastic skill to be learning, and this is a perfect time to do so. So I encourage you all to try this out, learn how to program, and hopefully it will help support you in your own career path.
Yeah, I mean, basically, thanks everyone for joining. I agree with everything Professor Rivers said. As I said before, I think programming, learning how to program, it's a super important skill to learn. I think it's analogous to like learning how to read and write. I think in the future, that's like the status of learning how to program is going to be. Like if you don't know how to program, it's going to be like you don't know how to read or write. So, whether you choose this program or not, I hope you do make the investment in yourself to learn programming, wherever it might be. Of course, obviously, we would like to see you here, but I think the more important message here is that you do that investment and learn this important skill. So yeah, thanks everyone for joining.
And thank you both, Professors Otta and Rivers, for being here and for staying all the way up through the end of our questions. And with that, we sign off here today with a heartfelt good morning, good afternoon, good evening, and good day to all of you from around the globe. Thanks again for joining, and we hope to see you very soon in the program.